So in this video, I want to talk about Earth beyond 6 of 9 planetary boundaries, the research article published in Science Advances. Let's just really dive into it. There's really no point in giving a big preamble to this. These are researchers from all over the planet, right? And these are the people that together have put forth a new framework, and essentially has 9 components, and we'll dive into each one of those components and how they are assessing it. But essentially it says that the planetary boundaries framework update, so they do this periodically, right? So every so often, every couple of years, there's an update to this because there's more data, they refine the methods. They find that 6 of the 9 boundaries they've developed have been transgressed, and what that means is that current conditions are outside of what's acceptable, at least to how we understand life on the planet currently. Well, life for us, humans, right, on the planet. And so it's a tricky time to be on planet Earth. But hey, not only environmentally, right, just geopolitically and economically, right? Gotta live through interesting times. So so it identifies 9 processes, this new framework. Anthropogenic, which just means man-made, and human activities have now brought Earth outside the Holocene's window of environmental variability, giving rise to the proposed Anthropocene epoch. So each epoch, I don't know how to pronounce that word correctly. So history is divided into these periods, right? Or natural history anyway. And each history has a unique climate, and with it, unique flora and fauna, right? So now apparently we're living or moving into the man-made epoch. So there you go, right? So paleoclimate research, however, documents that Earth has purely experienced largely free ice conditions during warm periods. So yeah, I mean, there's nothing to panic for the planet, right? So the planet is still the 3rd planet from the sun. It's going to keep spinning around the Earth, or around the sun, for another, at least my understanding is another 4 billion years. So probably long after humans are gone, the Earth will still be here. Life on the planet, however, will be probably very, very different, as life is now from when the Earth was recently formed, right? It's just natural cycles, right? What is, I guess, interesting for us, because I've moved beyond the alarm. I don't think there's really nothing to worry about. I shouldn't say it that way. There's nothing to panic over anymore. I mean, it's clear that humans were probably not going to do anything meaningful to address climate change at this point. So you just kind of have to mitigate as best you can and adapt. That's pretty much the 2 avenues I personally believe that are really left to us, right? Preventing climate change is unrealistic. It's already here, as we're about to see. And just changing people's behavior is it's practically impossible, right? Unfortunately, humans, we wait until we're inside of the crisis or going through it to change, right? And that can be said about groups as well as individuals. So it is what it is, right? So anyway, the planetary boundaries framework, which is proposed in this by these scientists and updated periodically, basically delineates the biophysical and biochemical systems that regulate the state of the planet within the ranges that are historically known and scientifically likely to maintain Earth's system stability for life support systems that we depend on as humans, right? So I guess that's a pretty complicated way of saying that even though humans, we might be able to, if it's cold, we put on a blanket or something, or a sweater. If it's hot, we just try to get air conditioning or fans or something. The plants that we depend on to produce the food, the chemicals, the animals on which we depend on to produce what have you, if they're farm animals, right? They only live within thrive, I should say, certain temperature ranges, right? If you disturb that, obviously it has direct consequences for us humans. It's just plain and simple, right? So anthropogenic perturbations, which just means man-made disturbances, are causing climate change, biodiversity loss, and pollution, right? Which is, again, not surprising. So the article does talk about the fact that There's still a lot of uncertainty in these models, and models is just a fancy term for a mathematical equation trying to describe each one of these systems, and then they've combined it, right? You can read the article, I will link to it below, and go into the nitty-gritty of the methodology. I do want to spend most of the time in this video looking at the graphic, and then we'll look at the table, right, the actual numbers. So this is pretty straightforward. 6 of the 9 boundaries are transgressed. Transgressed, you'll see, is really with purple. Most of them, the biosphere integrity one, the genetic diversity, so the loss of species, is pretty staggering. It's pretty out there, right, even among this graphic. So if it was only green, you'd be operating within like a safe zone that they've developed, right? Those would be stratospheric ozone depletion. So I remember when I was a kid, the loss of the ozone layer was like a big thing. And then they banned HFCl, hydrofluorocarbons, right? Those chemicals that mostly come from refrigeration, if I remember correctly. And the ozone layer repaired. So, things can be reversed, right? Atmospheric aerosol loading is okay. Ocean acidification is okay. However, if you actually read the article, you'll notice that it's going in the wrong direction, so it's not good. Novel entities, I actually do want to talk about that a little bit more, just after we get through the more straightforward ones, because this one's actually tricky and it's practically impossible to measure, as we'll see. But 6 measures are actually out of whack, so to speak, right? So land system change. So basically, the way they define that one is by the loss of forests. And I think we can all agree that, again, I've said it before in other videos, right? Nobody knows the exact same number of trees on the planet, but we all know that they're being cut down. Right? It's pretty obvious, right? So biogeochemical flows, so nitrogen and phosphorus. Nitrogen is important for the agriculture, right? So we have modern agriculture thanks to the Herbert Bosch process. And it's a fertilizer that you're always going to need in agriculture, right? Whatever crop you're growing, you're going to need nitrogen. Also, for our bodies, right? We need that for protein synthesis. Phosphorus, which is important for ATP, which is the energy molecule in living organisms. And then climate change, right? So carbon dioxide concentration, which we'll talk about that in the table, and radiative forcing. And let's just actually dive into the table so I can talk about these a little bit more. At the time of the recording, so atmospheric carbon dioxide, right, parts per million, the planetary boundary is 350. So before the industrial era, there was 280 parts per million of carbon dioxide for a long time, millions of years, right? Stable. It wasn't exactly 280, but it was more or less in that range, right? The upper end zone of increasing risk is 450 parts per million. This paper was published in 2023, so it's probably based on 2022 data. Those of us that know how this publishing business works, it takes a while to get your stuff out there. So the reason I'm saying that is because I checked this morning when I recorded this video, and it's 427. So we're close. We are very close, to the actual 450 parts per million, and that will make it 7 indicators that have been transgressed. And the table just shows you the actual number. We should be upper end of increasing zone of risk for the change in biodiversity, genetic diversity, which they measure it as the loss of a species per millions. And so it's more than 100. Pretty much every indicator you want to look at, it's over the limit, right? So upper end zone of increasing risk for stratospheric ozone depletion, the pre-industrial era was 290. We're close to it, right? So 284.6, and the upper end zone is 261. Ocean acidification, as I said, pre-industrial was 3.44. So the ocean has been more acidic at times, but it's again, we're trending in the wrong direction. And so on and so forth. It's not that I've adopted a defeatist attitude with respect to climate change, but you kind of come to realize that, it doesn't seem like we're going to be able to do anything on a global scale, especially now with how geopolitical tensions are folding out. And it's not good. That's all I can really say. This novel entities. So the way they've defined it is a percentage of synthetic chemicals released to the environment without adequate safety testing. So the planetary boundary is 0 because the planet didn't produce synthetic chemicals, right? The pre-industrial Holocene base was 0, and the upper end zone is unknown, and the current value of control variable has been transgressed. How do they know that? If they don't know how to measure it, and in the previous, there's no benchmarks, so to speak. And the reason is very simple. It's because, have you guys ever heard of PFAS? I'll talk about that in another video. But those are forever chemicals, and those are thousands of chemicals that when they interact with each other, it's practically impossible to understand how that plays out, right? And so that's never been seen in the history, at least of the planet, right? We've synthesized that for needs, mostly industrial use, some of it in agriculture for sure. But yeah, so the human body didn't evolve as far as we know, and life didn't evolve as far as we know to break down those chemicals. That's why they're called forever chemicals, right? And you'll find that they're practically everywhere. Yeah, pretty much anything. So if you're a human living now and you get tested for them, you probably have some quantity of it, right? And it's just stuff we've used in industrial processes. There was no ill intention whatsoever in that, right? It's just that we use these chemicals because they made industrial processes easier, faster, less expensive. But the consequences of that, obviously, we didn't know at the time that they were being used. Now they're in an environment and they don't break down because they're not natural, right? And so they go from, for example, if it's like an industrial chemical that it's poured into the river that then flows into the ocean, and the ocean is in the northern or southern hemisphere, it flows into the other hemisphere, and then people on the other side of the planet may be drinking or using water for purposes that have nothing to do with an industrial use, and nonetheless they get pollution, right, from a source on the other side of the planet potentially. Again, this is not to put blame on anybody. This is not this is evil or there's some secret agenda. It's just stuff that we've done that we had no idea what the consequences were. And now that research and science have caught on and developed new techniques to be able to assess these things, we find out that they're not so good for us. But, it is what it is. So let me know what you all think about this article, and have you read it? Are you keeping up with this type of stuff? How do you deal with mental anguish that comes from reading these types of things? We shouldn't fall in despair, but it's just reality, right? We have to talk about the things that are happening, because then this serves as the basis for policy interventions, right? So, for example, not too long ago, I know that the French government has moved to ban PFAS altogether, but that has consequences, obviously, for industry, and then they have to search for alternatives, potentially making stuff more expensive. So those are the dynamic interventions, how they unfold. And nobody said it was going to be easy, but sometimes, decisions have to be made, right? So anyway, with that, let's keep the conversation going.